This video is all about electromagnetic spectrum. The learning outcomes or the objectives are the following. 1. Define electromagnetic spectrum or electromagnetic waves. 2. Identify and enumerate the 7 regions of electromagnetic spectrum. 3. Define and arrange the orders of 7 regions of electromagnetic spectrum from decreasing wavelength to increasing energy and frequency. Let us first define what is electromagnetic spectrum. The electromagnetic spectrum is the range of all types of electromagnetic radiation. The waves of energy are called electromagnetic because they have oscillating electric and magnetic fields. Electromagnetic waves are waves that are created as a result of vibrations between electric field and magnetic field. Scientists classify them by their frequency or wavelength, going from high to low frequency or short to long wavelength. The picture illustrated shows that it begins in lower energy, low frequency, and long wavelength to higher energy, high frequency, and short wavelengths. So this means that radio waves has the lower energy, low frequency, and long wavelength, followed by microwaves, infrared light or visible light, ultraviolet rays, X-rays, and gamma rays has the higher energy, high frequency, and short wavelength. Radio waves. Radio waves are produced by the acceleration motion of charges in conducting wires. They are used in radio and television communication systems. They are generally in the frequency range from 500 kHz to about 1000 MHz. The AM amplitude module band is from 530 kHz to 1710 kHz. Higher frequencies up to 54 MHz are used for short wave bands. TV waves range from 54 MHz to 890 MHz. The FM frequency modulated radio band extends from 88 MHz to 108 MHz. Cellular phones use radio waves to transmit voice communication in the ultra-high frequency or UHF bands. Microwaves are the highest frequency electromagnetic waves that can be produced by currents in macroscopic circuits and devices. Microwave frequencies range from about 10 raised to 9 Hz to the highest practical LC resonance at nearly 10 raised to 12 Hz. Since it is possible to carry more information per unit time on high frequencies, microwaves are quite suitable for communications. Most satellite transmitted information is carried on microwaves, as are land-based long-distance transmissions. Radar is a common application of microwaves. By detecting and timing microwave echoes, radar systems can determine the distance to objects as diverse as clouds and aircraft. A Doppler shift in the radar echo can be used to determine the speed of a car or the intensity of a rainstorm. Sophisticated radar systems are used to map the Earth and other planets with resolution limited by wavelength. How does the ubiquitous microwave oven produce microwaves electronically, and why does food absorb them preferentially? Microwaves at a frequency of 2.45 GHz are produced by accelerating electrons. The microwaves are then used to induce an alternating electric field in the oven. Infrared waves. Infrared waves are produced by hot bodies and molecules, sometimes referred to as heat waves. This is because water molecules present in most materials readily absorb infrared waves. After absorption, their thermal motion increases. That is, they heat up and heat their surroundings. The range of infrared frequencies extends up to the lower limit of visible light, just below red. In fact, infrared means below red. Frequencies at its upper limit are too high to be produced by accelerating electrons in circuits. But small systems, such as atoms and molecules, can vibrate fast enough to produce these waves. Visible rays or visible light is the narrow segment of the electromagnetic spectrum to which the normal human eye responds. Visible light is produced by vibrations and rotations of atoms and molecules, as well as by electronic transitions within atoms and molecules. The receivers or detectors of light largely utilize electronic transitions. We usually refer to visible light as having wavelengths of between 400 nanometer and 750 nanometer. Visible light is the most predominant and we enjoy the beauty of nature through visible light. Ultraviolet rays. It covers wavelength ranging from about 400 nanometer down to zero point 0.6 nanometer. It is produced by special lamps and very hot bodies. The sun is an important source of ultraviolet lights, but fortunately, most of it is absorbed in the ozone layer, in the atmosphere at an altitude of about 40 to 50 kilometers. Due to its shorter wavelengths, UV radiations can be focused into very narrow beams for high-precision applications such as LASIK or laser-assisted in situ keratomileusis eye surgery. X-rays. X-rays are invisible, penetrating form of very high-frequency electromagnetic radiation, overlapping both the ultraviolet range and the Y-ray range. There are two methods by which X-rays are created. Both are submicroscopic processes and can be caused by high-voltage discharges, while the low-frequency end of the X-ray range overlaps with the ultraviolet. X-rays extends to much higher frequencies and energies. X-rays are used as a diagnostic tool in medicine and as a treatment for certain forms of cancer because X-rays damage or destroy living tissues and organisms. The widest use of X-rays is for imaging objects that are opaque to visible light, such as the human body or aircraft parts. Gamma rays. Gamma rays have the smallest wavelength and the most energy of any wave in the electromagnetic spectrum. They are produced by the hottest and most energetic objects in the universe, such as neutron stars and pulsars, supernova explosions, and regions around black holes. On Earth, gamma waves are generated by nuclear explosions, lightning, and the less dramatic activity of radioactive decay.